Okay, thank you very much. Thank you for invitation. I will try to be quick, let us say. It is true what it has been said in this conference. The decarbonization is a problem. Actually, I was impressed. I was in a conference in Venice University 1 week ago, and a professor said that 800,000 years ago, the level of CO2 in the atmosphere was 150 parts per million. And it remains like that, for example, 200 or 100 parts per million for millions of years until we came to the Industrial Revolution. And in the last years, in the 1900, this level went from 200 to 400 ppms. And it's still increasing, and the speed is increasing. We cannot sustain this way of increasing the level of CO2 in our world. It's not only the effect on the atmosphere, the effect is also on the seas. The oceans are getting more acid every day, every week. So we are destroying our world. We have to do something. So being practical people working in the steel industry, we are used to put the hands on the things. We want to propose something, and not just to speak about theories, but to show you that something can be done from tomorrow, from today, actually. So, okay, the key pillars are, of course, carbon avoidance, carbon capture and reuse, and energy efficiency, because we are wasting a lot of energy, and also we are wasting a lot of material. So. It's bad to say, but we have also to reduce the consumption of steel per capita, which is something that in the Western countries we already do. It's not done in the Eastern countries yet, but we hope that they will do it soon. So circular economy, water conservation, all this is part of what we can do. But let us tackle the first point, the carbon avoidance. So what we can do in the steel industry to tackle this problem? Well, one thing is to use alternative processes which are already in place. For example, the direct reduction. And then the direct reduction with natural gas is a well-established technology, is already in place in different parts of the world. More or less 100,000 tons of this material is produced in the world every year, so there is nothing very, very new in that. But the new is that if you pass from the blast furnace BOF-based production to the DRI electric arc furnace, you already accomplished half of the steps that you have to do, because, or more than half, you have done 2/3 of the steps. Because you pass from 2,000 kilograms per ton of steel to 500 kilograms per ton of steel. So the targets of the European Commission for the 2030 could already be achieved with existing technologies. Then, of course, use of hydrogen and other things can be adopted. I will skip this slide just to gain some time, because we already said something about that. I want to focus a little bit more about carbon capture. As you know, Danieli, together with another Italian company, Tenova, we own a process of direct reduction which is named Energiron. It's an inheritance of the old HYL process that in the last years, from 2006 to today, we are jointly developing and promoting on the market. This direct reduction process has intrinsically one important thing. The capture of the CO2 is already an essential part of the process. So in this process, all the CO2 that is circulating in the process gas is captured in different ways, with amine washing or with physical pressure swing absorption, etc. And this CO2 is pure CO2 and can be used for different things. For example, for storage, underground for enhanced oil production, for food and beverage, etc., etc. We will give you some example of how our customers are already doing something with the CO2. So starting our task from the present day situation, for example, Ukrainian market where blast furnace is dominant, for example, but in all Europe it is like this. Actually, my colleague was mentioning about the ratio of electrical furnaces to blast furnaces all around the world. And we said also that the Americans are not so keen to work towards the decarbonization of the steel industry, but the Americans, 50 years ago, they were producing the steel 70% via blast furnaces. And nowadays they are producing 70% of the steel via electric arc furnace. So they did something. We Europeans did not do the same. So we have to move. So in any case, 50% of the step can be done via DRI plus electrical furnace. Then if you capture the CO2 with, for example, our system, and you do something with the CO2, even continuing using natural gas, then you go down to minus 67% of the emissions. And then if you use hydrogen, etc., you can go down to almost zero. I said almost zero, not zero. Why? Because steel is a solid solution, they taught us at school. It's a solid solution of iron and carbon. So we cannot avoid carbon in steel industry. Some carbon is necessary. So yes, we can avoid completely carbon in the direct reduction, for example, but we need to introduce carbon in the melting of the steel. Otherwise, we don't obtain steel, we obtain hot metal. And with hot metal, we cannot do what we want to do with all the quality of steel that we need to produce. So what are our customers doing with the CO2 that with the Energiron process we make available? For example, the oldest plant that is operating the CO2 absorption system is in Monterrey, in Mexico. Actually, there are two plants in Monterrey, and they sell the CO2 to Praxair to make Coca-Cola. So the bubbles of the Coca-Cola you buy in Mexico are done with the CO2 captured from an iron producing plant. Okay, so that's a specific smell of iron of the Coca-Cola comes from there. In Mexico also they use for other beverages. In Indonesia, for the food industry, dry ice, conservation of things like something like this. In India also they do, in Salav, in JSW, they do dry ice. In Emirates Steel, we have two big DRI plants. Each of them is producing more or less 2 million tons per year, and they are coupled with electrical furnaces using 100% of DRI. All the CO2 is used to inject into the oil wells to increase the production of the oils. We say it's not a very good example because we use the CO2 to increase the production of oil to produce more CO2. Okay, but well, they are making use of this CO2. Nucor in the USA, they sell the CO2 to Denbury Resources, and it is injected in the local CO2 pipe, which is collecting all the industry emissions and then pumping underground, so sequestration of CO2. And all those companies make money out of selling CO2. So it's not only a cost, it can be also a byproduct that can be sold for money. Well, of course, there are other side effects in switching from blast furnaces to direct reduction plus electrical furnace. All the pollutants that are typically concentrated in the coke making are cancelled with the direct reduction because you don't need coke. So, I mean, apart from CO and NOx, but also volatile organic compounds, the aromatic emissions like benzene, toluene, xylene, and etc. are reduced by almost 100%. And so this is also a contribution to that. Now, all the world is speaking about hydrogen. And of course, as we learned before about Midrex, also Energyron is ready to use hydrogen. Actually, due to the situation, the typical configuration of our process, hydrogen utilization is even straightforward because we have a gas circuit which is reutilizing the top gas exiting from the reduction of the iron ores, which is not completely used because of chemical equilibrium. And we firstly remove water, but just condensating it, cooling down the gases. We subtract the CO2 via the amine system, as we explained before. Then we compress and recycle, and we need a makeup. And this makeup can be done in different ways. We can do it with an external reformer, steam reformer. We can do using coke oven gases. We can do via coal gasification and use the syngas produced with coal gasification. We have plants like that. And we can use hydrogen. Why not? Hydrogen, by the way, is even easier to be used than CO as a reductant. And Dr. Wiesinger can probably explain something from his doctoral thesis. The kinetics is much quicker, and the fact that the reduction with hydrogen is endothermic makes less dangerous the reduction for what concerns to sticking, melting, sintering, etc., etc. Well, to make it short, we are already applying these technologies. The United States have funded a research with the Department of Energy in which we are present. Also, Vestalpine is present via the Texas plant in this research. And the idea is to develop a concept in the United States that use renewable energy to produce hydrogen, to produce steel with minimum emissions. But also this is something we are proud of. Hybrid is a collaboration of SSAB, LKAB, and Vattenfall in Sweden. This country has a lot of green electrical energy. Actually, they don't know what to do with electrical energy in excess. During the night, they are paying Germany to consume electric energy. So they decided, instead of paying for consumption, to produce something that can be stored. You cannot store electric energy like that. So they started with the idea, we transform the electric energy to hydrogen, and we restore hydrogen, which is a good idea because they can use hydrogen in the peak consumption moments, even, for example, to produce electric energy back from hydrogen. But then they had also another idea to transform their steel industry using hydrogen, since for them hydrogen is cheap because of this reason. And together with Danieli and Denova, they built a pilot plant in hybrid in Sweden, close to Luleå, and they tested the operation with 100% hydrogen because they wanted to see if all the theories that we producers of plant makers are spreading all around the world are true. And actually, they proved that there is no negative consequence in using 100% hydrogen during the reduction of iron ore. Next step for them will be to install a DRI plant of the size of 1.6 million tons per year, and we will do together this project, this dream project, in the next 2-3 years from now. Another project for which we were named the best available technology is SALCOS, which is Salzgitter low CO2 steel making. In Germany, of course, they have this idea to install zero carbon DRI production coupled with the melting process. And well, as I told you, this is more or less the trend in Europe, which must be supported by the public sector, because otherwise no steel producer, the first to install this technology alone, will die, because competitiveness is not, of course, possible nowadays, because hydrogen cost per kilo is in the range of 4 to 6 euros per kilo. And if you consider that you need more than 50 kilos of hydrogen to produce 1 ton of DRI, you end up with hundreds of euro of production cost due to hydrogen. If you compare with natural gas, even in Europe, it is 10 times more. So something has to be subsidized, of course. But in the next future, when carbon tax will reach in the range of 100 euro per ton, and when the new technologies will make available hydrogen at the level of 2 euro per kilo, then we reach a balanced situation. Of course, all the world should go in this direction. Otherwise, some protection of the borders must be applied to protect us against maybe Chinese or other product producers that will not adopt these solutions. Ukraine is part of Europe, no?
Thank you.
Okay, so let us go a little bit quicker. We have also one important project in Russia. OMK has ordered us more or less 1 year ago a new direct reduction plant for 2.5 million tons per year. It will be hot and cold DRI, ready for the implementation of hydrogen. They will also pursue carbon capture. They want to liquefy part of the CO2 and use it for different scopes. And it's a very important and challenging process. And we hope we will be able to replicate this project in other places in the Russian region. And I had some more slides about other solutions that we prepared for utilizing green energy, like, for example, the new technology of our digital melter with the Q1 so-called electrical part, where we get rid of all the old technology based on the, let us say, static var compensator, SVC, etc., passing through direct current. Why is it important? Because typically what you obtain from renewable energies sources like solar panel, etc., is direct current. Then you have to transform in alternate current. But in this system, you can use directly direct current. Maybe we can speak in detail personally if you're interested about that. And this is already installed in different places all around the world, and is working properly. These are the last references of our Q1 melting system. And of course, there are other areas, like, for example, the reheating furnaces, where you can avoid using fossil fuels. You can use electricity and induction heating, and of course, the futuristic hydrogen burners for the same reason. But I believe that it is a waste to use hydrogen to burn in the reheating furnaces. Much better to use induction heating, because it's more efficient and much less expensive. And then something even more futuristic, in our plant in ABS, where we produce special steel, we installed a pilot plant to see if it is possible to use the nature to capture the CO2. So we installed a very big installation for producing algae, spiruline algae, which can be produced. This microorganism, they eat CO2 and other things, and then we can produce food for animals. We can produce medicines and also cosmetics for the ladies and for the men also. And we have just started this experimentation with good results. We are still producing kilos per day, but we think we will increase the size of this green example of utilization of the steel melting technology. Okay, other things, recovery of low-grade heat. You know that typically the water in the cooling systems is the heat contained in this water is dispersed in the ambient because it is at too low temperature to be useful. Yes and no, because you can install Rankine cycles to produce electricity using organic components as a thermodynamic cycle. So we have done it in our ABS melt shop, and we are producing with some efficiency electric energy starting from the waste energy of the water cooling system. Some 1 megawatt of power is recovered. And also we can do something because, slag treatment is another area where we neglect that there are possibilities. But for example, if you have to calcine the CaCO3 to produce CaO for treatment of the slags in the electrical furnaces, you emit a lot of CO2. So why not to recover the white slag, for example, of the ladle furnace and use it back into the electrical furnace? We are doing it. We are now making briquettes out of the white slag that can be used, replacing 30–40% of the lime that we inject in the electrical furnace. So, okay, this is more or less a synopsis, a resume of what can be saved all around a big steel plant, applying different technologies. Of course, the iron production is the big contributor, 1,300 kilos per ton. Then an electrical furnace. All this is compared to the standard blast furnace BOF route. And every piece of the technology can give its contribution. And it's important that we work all in this direction. And thanks for the attention.